Let's try to get more comfortable with trig formulas, trigonometry formulas. I don't know whether in your math classes you ever encountered a thing called the unit circle. Some teachers like it and some don't use it. I like it. Unit means one, so they call this the unit circle just because it's a circle and the radius of the circle is 1. It's 1 unit long. And imagine that the radius of the circle is like a needle on a gauge, let's say, rotating around this circle. Okay. So now going down to the second line, as that needle rotates around the gauge, it stays 1 inch long, doesn't it? It never changes length. It just rotates. And as it rotates, you could measure, if you wanted to, how high is the end of that line off the bottom. So at 30 degrees, it's this high. When it's rotated up to 60 degrees, it's a different height. It's that high. And it turns out that when the line rotates to 30 degrees, if that arm is 1 inch long, the height above the line is ½ an inch. And when it rotates up to 60 degrees, the height of that point off the line is 0.866 degrees. And the ratio between that 1 inch long arm and the height is a ratio called sine. And as it rotates, now at the bottom 2 circles, as this thing rotates, you could also measure how long is that horizontal distance from the center out to that end point. When that line has rotated up to 30 degrees, if you measured that distance, you'd find that it's 0.866. And when that line has rotated up to 60 degrees, if you measured the distance, you'd find that it's 0.5. And the ratio between that 1 inch diagonal line and the horizontal distance is a ratio called cosine. Now, let's think about the fact that you can have what you call similar triangles. If you have a triangle that's got a 30-degree angle, and a bigger one with a 30-degree angle, and a really big one with a 30-degree angle, they're all the same shape, aren't they? Some of them are bigger than others, but the ratios between all those sides stays the same. Those triangles have similar shapes. And so if you have a triangle with a 30-degree angle, the ratio between the hypotenuse and this short side opposite the angle is always going to be 1/2. That short side, that opposite side, is half as big as that hypotenuse. Even when it's a big triangle, that height of that short side, that's opposite the angle, is 1/2 as big as that hypotenuse. No matter how big that triangle gets, it stays the same shape, and that's the ratio. And that's sine. The ratio of opposite to hypotenuse is called sine. And if you want to look at a 30-degree triangle and you want to think about, okay, what's the ratio between that horizontal leg and the hypotenuse? If it's a 30-degree triangle, that ratio is going to stay 0.866 to 1, no matter how big this triangle gets. So this is 8.66 to 10, this is 17.32 to 20, but the ratio stays the same. And that ratio between the horizontal leg, the adjacent to the angle, and the hypotenuse is a ratio called cosine. And, same 30-degree triangle, if you wanted to look at the ratio between that short opposite side and that longer adjacent side, that ratio is going to stay the same no matter how big a 30-degree triangle you have, and that ratio is called the tangent. And here are those ratios expressed in formulas. So looking at these sides of the triangle, just to remind ourselves, if this is an angle in here, we'll call that angle theta. That thing there is a Greek letter theta. If that's the angle, this side over here is opposite the angle. This side down here is adjacent to the angle, and the slopey side is the hypotenuse. The ratio between the opposite and the hypotenuse is the ratio called sine. The ratio between the adjacent and the hypotenuse is the ratio called cosine. And the ratio between the opposite and adjacent is the ratio called tangent. And so you have these formulas. Each one has just 3 terms in it, a term and a fraction. And you can rearrange those terms in any order depending on what it is you're looking for. We'll look at that in just a minute. So here I give you a few examples. Let's say you have a triangle with a 27-degree angle and a 12-inch hypotenuse, and you're trying to find the length of that horizontal leg. Well, who has a ratio between the adjacent and the hypotenuse? It's the cosine formula. Cosine is adjacent over hypotenuse. You can rearrange those terms if you're looking for adjacent. Hypotenuse times cosine gives you adjacent. Hypotenuse 12 times the cosine of 27 happens to give you this number, 10.69. That would turn out to be the length of that adjacent side. Let's look at some examples. So here's a triangle. Now the angle that we know is up in the top here. That's the angle, that 30-degree angle. X, is that the opposite or adjacent or hypotenuse? Well, thinking about a minute, you notice it's opposite the angle. So that X there is the opposite. And they tell us the hypotenuse, and they tell us the angle. How are we going to find that opposite? First, you ask yourself, what formula uses the angle, the opposite, and the hypotenuse? And it is SOHCAHTOA. It is sine equals opposite over hypotenuse. Okay? And we're looking for opposite, aren't we? So the sine of 30 is opposite over hypotenuse of 6. Okay, sine 30 is opposite over 6. We're looking for opposite. So let's do the same thing to both sides. We'll multiply both sides times 6. 2 6's cancel out. 6 over 6 is 1. We're left with 6 times sine 30 gives us the opposite side. And it turns out to be 3. Here's another triangle. This one isn't even sitting square to the ground. Here's an angle that is a 35-degree angle. Here's a 90-degree angle. We know that one side is 6, and we're looking for the hypotenuse. Okay. What formula uses the angle, the side adjacent to the angle, and the hypotenuse? It is cosine is adjacent over hypotenuse. That's the cosine is adjacent over hypotenuse. So the cosine of 35 in this case is 6, that's the adjacent side, over hypotenuse. Cos 35 equals 6 over h. Let's multiply both sides by h. Okay, they're still equal. Those h's cancel out. H over h is 1. H times cos 35 equals 6. Still looking for h. Okay, now let's divide both sides by cos 35. They're still equal. Those cos cancel out. We got h equals 6 over cos 35, which turns out to be 7.325. I'd like to show you a shortcut. When you have 3 terms here, 2 of them are in a fraction, and you're trying to find the one that's on the bottom of the fraction, you know all those multiple steps we just went through, multiplying both sides by something, dividing both sides by something. The net result we came up with was the same as if those two just traded places. The one that's out by itself and the one that's on the bottom of the fraction can just trade places. And when they do, you wind up where we wound up at the end, with h out there by itself as we were looking for. Okay, now go to the next quiz. It's labeled Trig Review, and answer a few questions.